Introduction for me, I work for IBM slash Red Hat, but I work for an IBM as a go-to-market asset and architecture, being involved with Kubernetes for the last 4 years. I'm an open source maintainer for creator of OpenWhiz and also open source maintainer of the project Knative as a Kubernetes plugin. And recently I went through the process of studying and going through the certification process. So this is we're sharing here our knowledge.
Thank you, Carlos, for that intro. Amazing. Hussein, please introduce yourself.
No worries. Thanks, Mohammed. Hi guys. I'm Hussein. I'm also a DevOps engineer / cloud architect at the Home Office currently. Well, a subsection of the Home Office in the UK, which is called the Passport Office. I've been working with Kubernetes and cloud native stuff for the past 4 years or so, and I've been mostly working with the cloud for the past 4 years. But my experience spans back to 10 years in IT. I work for organizations that serve the likes of Coca-Cola, Nestle, Ministry of Justice, and quite other big names. I'm not going to bore you with my life, but I'll be more than honored to go through a few scenarios with you guys today, and to have people like Mohammed and Carlos on board is even better. So yes, back to you, Mohammed.
So thank you, Hussein. So compared to these two legends we have here, I'm just a junior, so I'm still learning. So the main floor here is for them to share their expertise. So we just start straight in. So I'm basically a platform engineer. I've been in the field for maybe just coming to a year and a half now. I'm still learning, and I enjoy the contributing to the open source community. And so without further ado, let's just start straight in. And so the topics we have is are basically also to apologize. Omar could not make it. He had an event, so he cancelled, kind of fortunately. So it's us three at the moment. To start with, we'll basically go through the CKA and CKS topics, the main things that you should know. We've left the CKAD out because most of the things are covered in the CKA, more or less similar. And CKA and CKS, they have a lot of overlapping topics. So we'll go through a few examples and demos, and then we go through container securities, and then we'll have a discussion between Carlos and Hussein, as they are our industry experts, and they'll be discussing how Kubernetes will be implemented in production. So let's go straight in. The first topic we have that a lot of people, you can say, they find hard is network policies. So Carlos, take over.
Yes, let me see if I can share here. Let me share my screen. And I will, I can move this to the side. Well, I want to see the chat as people ask questions. So let me get someone a notes. Before that, just to give an intro for people that don't know. Do you see my screen?
Yep, we see it.
And these links we're going to share with the slides later. But the CK, this is a GitHub repo. If you're a technical engineer and work on Kubernetes, probably you know Git. The latest CK, you can find the 3 curriculums in this GitHub repo. Today we're going to concentrate more on the CKS, and the CKS is one that got released this year in January. It's called the Certified Kubernetes Security Specialist, and we're going to cover some of the topics, not all, because we don't have all the time here, but we pick a few topics that we found interesting. So from cluster setup, and I know a lot of people don't build their own Kubernetes, but knowing some of the basics of like what is a kubelet, the kube API, those are things that are always useful. Percentage on cluster hardening, things like Rbac. We're going to cover Rbac. System hardening is things about the operating system, the host, also access to external access, armor and seccomp. I'm going to mention a little bit of seccomp, but we're not going to cover this in deep. The other one is minimizing the microservice vulnerabilities, things like putting policies in place of like what are developers allowed or the CI/CD pipelines are allowed to create and catch those things with OPA. We're going to go see OPA today. Supply chain security, which is a hot topic lately, is around what are the best practices with dealing with Docker files, minimizing the risk and scanning images. We're going to cover that. Monitoring and logging. If we have time, we can show an audit log. And then a few things around covering malicious things. So yeah, this is also a session for you to learn how to fish. So that's kind of the terminology of like, we'll give you enough for you to find the resources, and then you can study from them. There's a GitHub repo by my friend Walid that is very good. This repo covers a lot of the resources that I used to study, and I guess Mo and others also use. The exam is 2 hours. You only have access to certain resources, so not the whole internet or Stack Overflow, just the Kubernetes docs, the GitHub repo. Documentations for Falco and Trivi are useful in terms of the exam, but that's what you get. You get a terminal. You need to know kubectl or kubectl and a VI. And then this is a good repo that covers all the areas that I mentioned. I think I did a PR yesterday on this repo. The version that the exam is today is 1.22. So this is something that you have to be aware when you're looking at the Kubernetes documentation. And then at the bottom, there's courses that are very good, recommended. What Walid, I also recommended. For example, Momshad has a good Kubernetes. If you're new to this, actually the Kubernetes security, CKS, you'd have to pass the CKA first. So by the time you pass CKA, you know a lot of things. And these are some of the courses. Linux Foundation offers one, and also a combo with exam. Killer.sh is a great simulator. You get a session. When you get the exam, you get 2 sessions, basically 2 tries. And there's also books and also blog posts. So this is a repo that at least Wally has, and I send people to this, and if I found useful things, I contributed. And I think the last thing is excellent blog post by Mo that I went and read the other day, and it covers a lot of the information that we're going to cover today. So with that, let's move on to the first topic. That is any problems from the chat of people seeing my screen? Oh yeah, that's a good idea. We can share the links. It'll be useful. So the first topic that we're going to cover is network policy, and this is a Kubernetes resource. If you go, this is like the information that you will be accessible when you go to the docs when you get a question around network policy. And network policy, basically what it is when you have a pod, and I have a picture here. So this is a picture that says I try to say you're giving a hug to a certain pods, or all of them in that namespace. So it's a resource that is namespace scope, and you select the pods that you want to protect from going out to the internet, right? Going out of the internet, or something accessing the pod. So it could be another pod from a same namespace, or a pod from the different namespace. And it could be in cluster or from the outside the cluster. So the idea is that you're protecting the pods that you're selecting. So as an example, let's see a practice example that I have here. This might make my fonts bigger for folks. Let me know if you have problems seeing the text. So one of the question that let's not talk about questions because we're not cannot discuss the exam. It's operated by the NDA. But let's say that you want to when you want to protect a pod or a namespace, you create a denied ingress. So let's concentrate about ingress, not talk about egress. But ingress means connections, incoming connections to the pods. So in this case, it's cumulative. So you can create one network policy, a second one, a third one, and then the union of those policies is what gets acted on it. And behind the scenes, these are like configuring the CNI driver for Kubernetes, and then eventually net filter or IP tables. But this is the interface. So this is a way that you can configure, like, I want nothing to connect to my pod sitting in this namespace. So if I do get pods, do I have a pod? I don't have a pod yet, but I can create one. So let's create a pod. I'll create a pod which says k run. I can say nginx, and I can create an image. I'll put a label on it called role. We'll simulate that this is a database. So there it is. There's a pod. People can see the screen.
Yeah, we can see it.
Yeah. So yeah. So I have a pod. If you do --o wide show labels, you will see that this pod is running in this IP address, and it has the labels roles DB. So if we create this network policy, just create it with the YAML, right? This is something that you may need to practice in the exam. It's like how to edit the YAML and there's YAML examples in the website. So you can grab this. So you have access during the exam. You can grab some of this YAML and then configure it. So that's what I did. So now nothing can talk to any pod. See the pod selector here. These brackets means that it's selecting any pod and it's not allowing any ingress to come in, and the ingress policy is empty. So so that's the deny. Then what about if we want to say that pods, we can even test this. So that's something that we can do. We can create another pod. We can say k run, let's call this one client. I'm in the default namespace, I think. Yeah. Always that's something a tip was just the namespace -n, and yeah, image nginx, and then let's put a label on this of role client. So this is the client to the database. So now I have two pods. Pod is the client, and then call it nginx. I should have called it database. Let me delete pod nginx. That way is a little bit understandable. So this one, since it's acting as a database, I'm going to put database in here. And now we can see, right, I have two pods, two IP addresses, and basically I want to configure it. So the ingress policy is present. So if I do k describe is one command that I like to use for network policies, because it prints, and this is the default. Yeah. So this one is saying that it's not going to allow anything to touch any namespace. So any pods, the DB cannot talk to the client cannot talk to a DB. But now I want to create a YAML file that says I want to allow either a client sitting on the same namespace or a client from another namespace, and that namespace is Alice. I'm selecting here a namespace, and then pods in that namespace also have the role equals client. So this is why if I create this network policy. I think that's the two I'm going to show today to make it very simple. And I'm going to select in here. So this spot selector is I'm selecting the database. So who's the one that I'm hogging? I'm going to apply ingress policy. So what things are you going to allow to talk to the DB pod? So like I said, these are kind of the rules. And I have two rules. If you see here, this is an array. So it's not an and, it's an or. So either or you match this rule and you are allowed to talk to the database, or you match this rule. So if we create this one, let's create this one. And now I have two policies, right? You can see the describe network policy. And I can see the two network policies. One is block all the traffic, ingress traffic to any of the pods. The second one is saying, but it's kind of a but, allow pods from the same namespace with the raw equals client to talk to the database, or pods sitting in another namespace, Alice, right? So let's test this. So if we do exec, and I do IT, and I select the from the client dash and default, and I want to talk to that IP address of the database. I need to get the IP address of the database, right? Is the database is 147. So let me grab this. So I'm going to basically, this command, what it does is it goes inside the client and it runs the core command just to make a connection to something. And that something will be this IP address. So let's see if that works. So it worked. I was able to talk to that database. If we delete that network policy, then I should not be able, right? So we can do delete network policy, and let's test it again. Can people see my screen okay? Let's see. I can make it bigger. People have problems seeing it. So let's try again to see without the network policy, that's allowed, and it looks like it's not. It's timing out, right? So let's create the policy again, and now we'll test the other scenario, which says a pod with the raw client, but this time sitting in the namespace Alice, can talk to it. But if not, it cannot talk to it. So let's see if we create this, right? And now I have the network policy. I put it back basically, and then I create a client, and I'm going to create this client in the default namespace. What did I mention? That is the namespace is Alice. Oh, it's already exists. So let me delete it just in case. Delete pod -n Alice. Let's create it again just to be sure that I'm creating it. So now I have a pod with this label, which I match, right? Sitting in a namespace Alice. So if I do get pods -n Alice, it's running. So I should be able to So now I'm allowed because I have the label. Raw client, I'm sitting in the namespace Alice. So if I do exec client, but instead of the default, I'm going to do it from Alice. It works. So what about if I change this to something else, say Pedro, right? So user Pedro, and we just switch it like a little bit and run it again. So that works from the namespace Alice. And then we'll create a namespace Pedro, and we'll create a pod in that namespace. And that will be the final thing. Run client in Pedro. I just created the namespace, right? Pedro. And I'm going to create that client there. And now I'm going to see if I can execute from Pedro to the database with the same thing that we saw that it just worked. So if we do this, if you're paying attention, put in the chat if this will work or it would not work. Make it a little bit interactive. You have a 50-50 chance of getting it right. If you're looking at this in the chat, do you think this will work, or you think this would not work? Would that pod be able to connect to the pod doing it from Pedro or not? It should work. I have someone says it should work, right? Because we saw in Alice it worked. So I just created a new namespace called Pedro. Let's show them the policy here again so people can see it. So basically, this is the ingress rule. And Greg says no. Oh, Greg Ackerman is here. I have a no, 2 no's and 1 yes. Okay. Good. I don't want. Okay, so yes, it should work. Okay, so we have yes and no. So this is the thing. If you're going to take the certificate, you cannot. You have to like do things, know why, and then if you're lucky, validate that actually you did the correct thing, right? And you only have 2 hours for 20 questions, so you really need to be very sharp. So let's give it a try and see. It doesn't work. Anyone can say why it doesn't work? Okay. Okay. Did not pass in raw client. No, it has the raw client. That part user Pedro, I guess. Okay. So the reason it doesn't work is because this thing here is saying these clients can connect only if the namespace has a label user Pedro. So if I and my pod has raw client, so my role has client. So the reason it's not working is because my namespace might be missing the namespace user Pedro, right? So I think I applied this rule, right? Let me double check again that we're doing things correctly. Yeah, it will not work. So the reason is if you do get namespaces, that show labels. I have autocomplete always in the exam, use autocomplete. You will see that Pedro doesn't have, it has a namespace and a label called Kubernetes.io metadata.name, which is new in Kubernetes equals Pedro, but it's missing something like user equals something, right? Like user Alice had it. And that's why I was able to do it. And I did it before here. I did it yesterday. So I did the exam with Pedro. So the thing that to make it work is we have to say K label namespace Pedro with user equals Pedro. I think that's what we want, right? From the namespace equals user equals Pedro. And one thing that I did by changing this in here that you may also hit in security or practices with Kubernetes is because I just make this to work with Pedro and namespace, I just made the other pods failed. So I should be getting PagerDuty saying the pods sitting in Alice stopped working because you changed the policy, right? And you mess up with the namespaces. So, but at least we got Pedro to work. So if we run it again, it should work. Let's run it again. Boom, and it works. So I think that's the end for network policies. What do you guys think? I took too much time on this one.
Yeah. Oh, that was good. That was really interactive.
Okay.
Thanks, Carlos.
Yeah. So let's move to the next presenter now. So that was network policy, just a taste of the couple of things that may come up in the exam.
Thank you, Carlos. That was very nice and informative, and it made sense. So let's move on to Hussein now, going through Falco now.
Mohammed, if you want to share your screen, please? With the
Yeah, one moment. Can you see now? Oh, there you go.
Come up. Falco. Okay, guys. So I know it's a bit of an abrupt jump from doing network policies to Falco, but we'll do it regardless. What is Falco? So Falco is a runtime security tool. It was originally created by Sysdig, and what they did was they donated that to CNCF. If you want to go to the next slide, please. So the way it works is you create rules within Falco, and based on that, you can, the way it works is you create rules within Falco, and those rules get, system calls in the Linux kernel, or the system calls made to Linux kernel will get like verified against those rules, and then based on if they match it or not, if there's a violation, then it gets alerted, and then you can put that alert in any system that you like to get alerted, whether you want to send it to Slack or you want to create log files out of it and put it in your dashboards and create dashboards out of it in the likes of Grafana, or use the name now of all of the other systems that you have for monitoring. So that's what you use it for. So the way it works is that, like we said, all of the system kernel, all of the syscalls made to the kernel are monitored, and once they are monitored, when they've been monitored, you have a list of rules within Falco that it gets matched against, and once there's a match, then there's an alert sent out that there's been a violation. So what kind of rules or what kind of calls can you monitor? Well, calls like privilege escalation. So if you're doing sudo within your application, or if you're doing sudo in the OS level, then you can pick that up. By the way, Falco is not specific for Kubernetes. You can install that on your Linux systems, but it brings added functionality when you use it with Kubernetes. So you can look at your privilege escalations. You can look at namespace changes. So if anyone is tinkering with the namespaces, you can alert on that. If there's any read or write on like well-known directories like user bin, user sbin, or any other directory that you choose, you wish to monitor, you can look at that too. If there's change of ownership or change of permissions on specific directories or files, you can alert on that, and all of the other different scenarios. If someone SSHs in, or if someone runs some sort of executable within your system, this can all be alerted on. So if you have a closer look at the rule, which is on the left-hand side, then you can see how this is defined. So within Falco, you would have like your config file, and within the config file, you can define different type of rules. So this is one example of that rule. So first line you can see is a macro. A macro is basically making like a reusable version of a code snippet. So someone can put in like the condition now. We've written the macro is open right, and then we have, if the event arg flag is contains the specific flag, which is or create or trunk or I can't really read it too well, but or read right, then you can, as in, contain that piece of snippet code. Instead of writing it again and again, you can use a macro to be able to define that. So in this specific rule, we have 3 different macros that we've defined. So which is the open right, package management binaries, and bin directory. So if the conditions get fulfilled, so the rule underneath it now states that if the conditions, that event directory, which gets, sorry, someone has wanted admission here, but if it defines that the condition is defined here, that if the event directory it's equal to, if there's a write on it, open write, which is all of the rules that we just defined up above, and the process is not the package management binaries, which is also defined up there, which is the condition is process name is dpackage and dpackage preconfigure RPM key. So if it's not that, then give me an output, and the output is what it's going to do, which is give you this message, and the priority is warning. So you can set different levels of priority. If it's critical, warning, and all of the different like info, whatever you do, define it depending on how it gets flagged up in your alerting system. So you can do that, and then it will send an alert out. Now you can set up in your config, in your Falco config, if that alert gets sent to system out or std out, or if it gets sent to a log file within your system, or if it gets sent to like a HTTP endpoint or gRPC endpoint. So that's all configurable via the falco.config. So to be honest, there was going to be a demo for this, but for the sake of brevity, we've defined a problem, and I'm just going to talk through it. Otherwise, it's going to take a long time, and it's going to be a lot of effort to install Cluster, install Falco, and run through the whole scenario. But if you see, is there a way of making it slightly bigger so we can read the problem here? Thanks, Mohammed. So as you can see, yeah, I think that's better. Thank you. So if there's a scenario, let's say we want to detect anomalies using Falco, and this Falco service shows frequent alerts. So we already installed it, and it's showing frequent alerts. The file below, and this is the alert that it gives us, which is file below a non-binary directory open for writing. Now it's our job to go and identify it and go make a change to that specific rule. So the output we need to change it to should be, we firstly need to make the priority critical, and the output should be file below a non-binary directory open for writing, and this user equals to username, file equals file name. So these are the components that's going to pick up from the OS and populate it, so the message becomes more meaningful to us when we're reading it. And alerts are logged, so we're going to change our logged alerts to be pointing to a specific directory there. So how would we accomplish that? If you go to the next one, please. Thank you, Mohammed. So now, like we said, Falco does have a config file. So the config file lives in etc falco.yaml. So it's a YAML file. Within there, we can go and we can go to the subsection which tells us where we need to send our output. So we can turn that on. So this then helps us with the requirement that we need to send it to a log file. So we'll come here with enable the file output, which is a section where we define that it should be a file output instead of std out, or if we're sending it to a different endpoint. So we've turned that on, and we'll give it a file name where it should be logging this. So that the requirement has been fulfilled. So our next step would be to go look at all the rules where the Falco rules have been defined, and then we go make change to that specific rule that we've been told that this is a problem here, and we need to go change that, and we need to put the information that we've been given before. So now we'll go to Falco. Once again, the files and the rule files are in etcd Falco rules. There's two files where the rules are defined. There's Falco rules.yaml and Falco rules.local.yaml. So local YAML just appends it to the Falco YAML. So if we find out which rule it is, what we can do is we can move that rule to Falco.yaml or just make a change directly to it. So what we will do is we'll go to that rule, like we're doing. That rule is defined by a snippet where it's defined by rule first. You give it a name, which is right below binary directory. You give it a description, which is stated there, and then you give it your condition. And the condition again is that the bin directory and the events directory are open for write, which are macros probably defined that we have in. Well, you can use it again, but You can create a snippet if you're going to be using the snippet again and again. You can create a macro out of it, but for now, this is fine. And then we're saying that obviously the packages are not management, the packages that are accessing these bin directories and the event directories are not your package management directories. If it's Yum, if it's package and new package for Debian, if it's Yum for CentOS and all of that. And then obviously it's not Docker doing something with the bin directory or the events directory, and similarly Python or other components that you know that other known packages and other known software within your system that does quite a lot of that, which are safe and you know them, then you can add them to the exception list there. That if they're doing it, then do not give this output. But if it's like any other user apart from that, then give us the output which you've defined there. Would be file below a binary directory open for writing. So someone has opened the file, which is not the file, not the users that we've defined already, or not the processes that we've defined already. And then you give it the username, the file was updated, the name of the file, and the command that was run. And then we've created priority of critical. And then we've also given a few tags, which is file system and MIT persistence. So we've done that. Once we've created that, now we need to restart file code so that this signal can get applied. So you can do that by running the following command, which is kill setup, and then you run it again. And then based on that, it should now the rules should take effect, and it should alert on the conditions that you've set there. And I think with that, it's pretty good. I'll get it pretty slow, but that's in brief of Falco. Is each one of these topics is quite vast. We can spend hours and hours just talking about Falco, and it can be, I think, quite tedious. But for the sake of keeping this within the 2 hours, because we've got a lot of different components to talk about, we'll keep it quite short. And that's Carlos put in the chat. You can install Falco using Helm, so you can play around with it. If you've got Minikube or kind installed on your local cluster, just bear in mind that within if you're using Mac or some other OS, then it might not play ball because it needs Linux syscalls to be able to make some of these. So I was trying to get it working for a demo just before this. I'm using Mac and it wouldn't play ball with it. So you might need to do it on a Ubuntu machine that you spin up, like an EC2 instance of that. So just to get hands-on with it. And yes, back to you, Mohammed. Any questions, please ask towards the end of the session, and then we'll answer that. Mohammed, back to you.
Thank you for saying that was a heavy topic, and Carlos as well. That was 2 heavy topics. We'll take a light one now. So move on to some mounting secrets on pods, and it's quite common in the CK and CKS, and it's something that you normally do in production because it's more secure than mounting secrets into as pods, like as an environment variable, or just hard coding it. That's not good practice. So I'll quickly go through with you guys like good practice, basically, what you should do when you make a secret and how you should mount it. So can you guys see my screen? Is it clear?
Make it a little bit bigger.
Bigger?
Yeah, just the font, please. Command plus should do that job.
Yeah. Is that better now? Clear? Or still is bigger?
Yeah,
that's it. That's a good one.
All right. So we'll just start with a make a quick secret. So I think you should have a namespace called seminar. So let me just double check. Get namespace seminar. Yeah, okay, it exists. That's fine. So we basically start with the creating a secret in the seminar namespace. So we do k minus a namespace, the seminar namespace, and then you create secret. And there are different types of secrets, but in this case we use a generic secret, and we'll call that secret 1. Okay. And there are different ways to insert a secret. You can do it through file, through literal, by typing it in. But to keep it simple, we'll just do from literal. We'll have 2 values. So the first will be user equals admin. Of course, when you're doing this, don't show it to people. But yeah, admin, and then from literal again. So our user is called admin, and then the password will be called, just make a password for it. So let's call it password in a more Let's do this, and then create secret. So now we've created a secret, right? If we do get secret, we should be able to get the secret, and it will show us the secret that is decoded, or sorry, coded in coding format. So if you see it in OYAML, you see the secret is coded in base64, right? So what we do is we'll mount this secret as a volume into a pod. So how we do this? Let's go to documentation and type in secrets, and documentation is quite useful actually. So you use it quite often. We'll look for secrets in a volume. That's it. We're looking for this. So we can copy this in and then change up what we need to copy change. So go inside here and let's just do secret.yaml. Let's copy that in. So let's change the name of the pod, call it secret pod. Change that as well as the container, keep consistent secret pod. Use the image as nginx. The volume mount, when you change this, make sure that is the same as the volume name here as well. So volume 1, and the mount path is a path that will be used inside the container. So we can just keep this and just do etc. Yeah, keep it as foo. Read only, so it's more safe and you can't change around. And then for secret name, literally what we created now. So we create a secret and we call it secret1. That's good to go. And also we missed something. You can spot it. We're trying to create the secret in the namespace seminar. So we add namespace here and then save it. Now we can apply this. So secret, apply secret. Sorry, not secret, the pod. Yeah, it was called it. Yeah, that's what it's called, right? So we've created the pod now. So let's obtain that pod. Make sure it's running. So get pod. So it's still creating. Let's watch it. Okay, it's running now. Cool. So to test out that the secret is there, what we do is we'll exec into it. So in the seminar namespace, we'll do exec minus IT interactive. The pod was called secret pod. And then we'll open a shell inside it. Okay, we're inside. So now we can go into that. So let's just do cat. Or let's see into it. Remember the path we selected was etc. and foo, right? So let's go to etc. and then foo. So ls areas. So if you cat this, we should be able to see what we put earlier. So cat user, the admin is there, and then cat the password is also there. There we go. So that's pretty much it. Creating a password and putting it into a pod, and that's pretty much it. And if you want to, there's another way to decode it. Normally you would do, if you just do -n, you can use base64 decode to decode it, but we won't do it now, and we'll move on. So that's pretty much it. Creating a container, a secret, mounting it into a pod as a volume. So that covers that basically. So we've done that, create the pod, and create that as well. Now we can move on to Rbac. So Carlos, take over. Thank you.
Thank you. I was trying to make the session a little bit interactive. I asked 2 questions to the attendees to see if they want to answer quickly before moving on. Of how long is the key of the base64 cipher being used for encryption? Anyone knows? Okay, I think that maybe there's some delay. So the reason for the question is base64 is not encryption, is obfuscation. It's not encrypted. So if you are transferring information in base64 and you get information from your Kubernetes cluster and you copy paste this to somewhere, please do not. And also do not use a public website to copy paste that base64 text to get it back. So that's the question. That number 1. It's base64 is not encryption. And the second question was around what was the second question? I forget. What was the main reason secrets in Kubernetes, kind of like you're interacting with the API server from the client, is base64? That information that you get back from kubectl. What is the main reason that is base64 versus being config maps that is text? Okay. Yeah, so the main reason that was chosen to be base64 was to transfer binary data. So for example, you have binary data, it could be bytes, it could be picture information, or anything that you want to save as secrets. Usually you don't have pictures that are private, but if you have a picture that is private, right, you can store it in a secret. And secrets and config maps by default is 1 meg of size. So I just wanted to make it a little bit interactive. So, and somebody said something about KMS. Yes, I think at the end we're going to talk about using secrets in production and those type of things are involved. So the next section is Rbac. Let me see if I can share. Share my screen and let's do a little bit of Rbac. If I can. So I'll take over Rbac. I share some links on Falco. Falco is very good. I describe it as the alarm system or the cloud-native alarm system of Linux. So the next topic is, let's take a look at Rbac. And Rbac is a way of configuring access to the different resources in Kubernetes. Basically, it's how the Kube API server, right? It's a REST API. It's going to either authenticate, allow someone a service account or a user that belongs to a group to allow to do interactions, basically crowd operations with the Kube API server, either to create a resource, delete a resource, list a resource. There's other operations like impersonate another user, or for example, use a resource like a PSP. So with that, Mo created kind of a question on how to, that could come in the exam. So we'll do it together here. And the thing is, I like to use the command line. You can do the Rbacs by YAML. Usually, typically in production, you will use YAML, for example, in GitOps. You will put your YAML there. But and if in the exam, you can, if you have a question that requires a little bit more example in terms of use or impersonation, YAML is very good. So if we go to the resource, Rbac Kubernetes, and again, bookmark these websites, or just bookmark the Kubernetes website, go to documentation and type Rbac here. You're not allowed to use Google during the exam or any search engine. So, but you are allowed to save bookmarks to the different pages in the website. So Rbac, this is an example of the YAML of defining an Rbac, and basically an Rbac is the role represents the access, and then you do a also role applies resources within a namespace, so there's namespace scope, and then there's also a cluster role, which is a cluster-wide scope, and an example of role versus cluster role is in here. You see a pod, a config map, a secret, a service account. Those are resources that live within a namespace, and you can have the same thing, the same resources with the same names in a different namespace. Cluster role are things like namespaces, right? The namespace itself is a cluster role, or a validation webhook or mutation webhook, or a cluster role itself is a cluster-wide resource. So for example, if you want to avoid someone from deleting a namespace or creating a namespace in production, then you don't give them that access. But you want to do it in a CI/CD pipeline, then you have to create a cluster role to give that access. So with that said, let's move on to the exercise. I didn't talk about the role binding. So that's kind of the access, and then how do you apply that access to different people, right? Users or service accounts or a user. So a role you create a role binding. So a role binding says these subjects, we call them subjects, are going to get this role. So they kind of like adopt that role, and this role in here could be of type role. But if you can see here, this might be important in the exam, is you can create a role binding that gives Jane the role pod reader, but you can also give Jane, the user on that namespace, a cluster role that says view or edit, like the cluster edit or the cluster admin, meaning that that user can do all those permissions, all those verbs against those resources, but in that namespace, even though the cluster role's definition is cluster wide. And then the same thing with cluster role binding should be down here, cluster role binding. So let's go back to the slide to see what the slide we're asking us. Create a namespace account, name seminar service account in the namespace seminar. So this is following along with the exercise that Mo did. I can do this one. You do this one in VS Code here. I think I had it up. So it said, I already forgot what it said. Put it here. So create a service account. The way we create a service account is create service account, SA. You can use, I don't know if people know this. Sometimes I use the short name, the short name for these resources, like NS, instead of typing namespaces. The way you can know this is API resources. You can do K API resources, and then this will give you all the resources in the cluster, and then this column here give you like the short version of the resources. So instead of typing pod security policies, you can say PSP. So that's just a tip. So I do create service account, and we said that it was going to be set and then namespace. We have to create a namespace first. Okay, create namespace. I will call it seminar. And the only issue I have, I know Kubernetes, the only issue I cannot type. Okay, create namespace seminar. So we create a namespace seminar. So if I something about context, this is not my new context. So I can switch the context to there, or always put the -n. So that's something you have to pay attention in the exam. If you want to switch context, you can do kubectl config set context something. Well, I'll use another tool. We can do kubens. Let me see if I do kubens. Yeah, and then I'll do seminar. That way I don't have to pass -n seminar. And then the next thing it says, wait, I did that. We'll put this one at the top here so I can see it. And then it says create a new role named Kubernetes seminar that in the namespace seminar, which only allows create and update operations only on resources of type pods and deployments. So I think what we want to do is do create. Did I create the service account? I don't think I did. So create service account seminar-sa. So that was created in the namespace that I'm located right now, seminar SA. And then it says create a role. So one cool thing is you can do create role binding, create cluster role. And the good thing, if you use the help has all the flags in here. but the help always have examples. And this goes for most all the commands in the Kubernetes CLI has good examples in here that probably has 80% of the information that you need to answer a question, and also like at work, right? So I can look at these examples, and then at the end, I can also see the usage, right? That says, how do I create a role? So if we want to create a role, I will do create role, give it the name, Kubernetes seminar, and then in the next space, so I can put -n, be explicit, right? Or I'm already in the context. I always like to be explicit because it depends on the CI/CD pipelines and things like that. And then --verb. What do we want to allow? Was create and update. And then we wanted to do for resources equals to pods and deployment. I think that's it. So whoever has this role is going to be able to create and update pods and deployments in the namespace seminar. And that created the role. So now it says create a new role binding, name KS seminar, binding the new created role to the service account that we just created. So now we want to give that role to the service account. So we're going to do the same thing. You can do create role binding, and if I don't remember, do /h, and I can see examples, right? Like I said before, all the flags. And the trick here is if you are, so we'll do it now. Create role binding, we'll name it KS seminar bind. If I can type, and then to the service account. So I'm going to bind the role that we created, and the role was KS seminar, and then the next thing is to who I want to apply that seminar. Is it a groups? And then you have to specify like this, group name. If it's a user, then you specify like this. But if it's a service account, then you have to specify like this. So it's a service account, and we need to put in here the namespace that service account is located. Even though that you're in that context, you have to put the namespace in here. So we'll put service account equal, and then the namespace is seminar, and semicolon, and then the column, and then seminar, and then the name of the service account, which is seminar-sa. And I did something wrong. Oh, I took too many dashes in the service account. I don't know if people can see this or not. Right? And if you want to validate what you created, you can do describe, for example, describe the role that you created, right? So it says, and this is a nice printing way, right? So the verbs is, I can create and update pods and deployments. So this role can do that. And since it's a role, this is applicable to only a namespace, not cluster, right? And then I can do describe role binding, and put the binding there. And then it would say that this binding, this is not printed a little bit or less. So the role is applied to this subject. And that's how you do it. One thing that you can do is use something called auth, and you can say, can I auth, kubectl auth, can I create pods as user, right? System user account or as a user, and it will give you yes or no. So with that, it's something that you can use to validate. I'm not going to do it now because of time, but that's kind of like the mechanics of creating roles and cluster roles, and role bindings and cluster role bindings. So that's for Rbac. I think we're doing good on time. Questions so far? I think Mohammed put the commands in there. They're available here also, and we'll pass it along to the next section, which is
Thank you, Carlos. We've got
container security.
Yep, thank you. So moving on. So container security is still part of some of the questions or some of these things you learn concepts are still part of the CKS. So it's still beneficial for you to learn, and in general at work, production, it's good to know how these things work. So to start off, we'll start with Dockerfile best practices. There are a few things that you should know. So to go straight in, we'll show you a bad example of a Dockerfile.
Are you showing your screen, Mohammed?
Oh, I'm not sharing my screen, am I? Sorry about that.
Thanks.
Okay, so can you see it now?
Yep.
All right, so here's a bad example.
Yeah.
All right, so I want this to be interactive. So write on the chat, what are the issues that you see here, and like what should be, updated and so on. So write on the chat. I want to see what you guys are thinking. Okay, and still spelled wrong, yeah. Thank you.
Yeah, people saying really useful command. Oh, install, spell.
Okay, nice. So your user root is our first one. That's correct.
Yeah, typo.
Yeah, that's a big typo from me. Sorry about that.
User root. Why is it wrong? When you use root, everything works. Latest tag. What's wrong with latest? When you use the latest software, you're more secure. Have all the latest patches. I don't know what people are thinking here.
I'll say these type of suggestions.
Nice. So we've got user root. Yep, that's the first one. Major issue. So Carlos, can you explain why we should use root? Or Hussein, can explain why we should use root?
Yeah.
Or somebody in the chat can say it.
Yeah, go on.
Someone wants to answer in the chat. Why is it a bad idea to run as root?
That's correct.
It's elevated privileges. Yep.
Yep.
I
So that's
think
the first one.
Why is that a problem?
Deepgram has that around.
Why is being elevated a problem here in the grant?
Yep. Container. Somebody says container escape is easy when running as root.
Nice.
That's a good answer, Adi.
Yeah. The next one is latest image. So what was the reason why we shouldn't use latest image? Someone said
latest. Why we don't want the latest patches to all the security issues?
Non-determinism. That's it. Yep. And Jason said that as well. Yep, that's correct. So we should specify a version basically. So whether the latest version is or the version you want to use, basically specify the version. That's the second one. So after root, that's that one. Just ignore the spelling for now. That was a error from my side. Another thing is, what's the third one? That is somewhere here. Yep, you should have one single run.
There.
Nice, yeah. Single run command. Why should you use one run command instead of 2 or 3 or 4? Yes.
I think Ali got it.
Very nice. Yep. To make a lighter image as well, yeah.
And it's on fire.
It's on fire indeed.
Yeah,
that's
so
pretty much it.
Yeah, less layers, right? Every one of those commands will create a layer, and you want to have as less layers that you can.
There's one more thing I think you mentioned, Carlos, before we had a chat. What was it about? It's about the expose, if you remember.
Oh yeah, expose is a nice when you put expose and a port number it's not as related to security, but it's a best practice, kind of be kind to others, right? So if you are writing a Dockerfile, maybe you are in operations, or you're a developer, hopefully not writing Docker files, but let's say that you're a Docker, you're a developer writing Docker files. You write the application. Your application is maybe a web server or maybe a database or something, and you don't put expose. So expose is something documentation. And one of the misperceptions that I see in the field is that people think that putting the expose and a number makes the software serve, accept traffic in that TCP port number or UDP port number. So using expose is a documentation thing of you're documenting like my application. If you don't specify a port through an environment variable, which is kind of also is the best practice, that'll be the default. And also in container tools that run containers like Docker or others, sometimes they take those expose fields as if you want to expose all of them and give them dynamic ports to expose them. That's also useful there.
Nice, thank you. So,
and do we talk about multi-stage? Why is it good for security? Go ahead, Mo.
Go for it. Take over.
Hussein, why do we want multi-stage? What we call like building one layer and then running a different layer.
Sure. So you can keep the level all the different binaries that you download during the install stage. So you can use two different containers. So one which builds the next container, and then you actually use the other container to be able to, or use the other image to be able to run your actual production workload. So you just separate all the extra things that get downloaded while you're building your container. So that way there's less exposure for any security risk.
And then the end result should be your container should have as minimum files as possible, and there's something called distroless or scratch containers that they're built. For example, in Go is a common pattern where you have the first layer builds your Go code, so it needs the source code, it needs the Go build, the Go tools, right? Any data that it needs to download. But your application, when it runs in production, runs in Kubernetes, the only thing that you need is maybe the static binary, like the one file. So by having one file, container with one file, it reduces the risk of that binary using something in the file system, or somebody finding something in that file system, injecting itself in there and then using it for something else. That's kind of like there's a doc. We can share the link. From Docker. There's a best practices Dockerfile link that I point to. It's very useful.
Yeah.
There's one by Google also as well. They shared.
Yeah, we can share that one also. Best practices Dockerfile.
Do you want to show
and many
good examples?
Yeah, many systems.
Yeah.
Gone.
You're always saying gone. Yeah. So moving on. That's basically the good practice, and so you identified it. So the user
and it comes in the exam. So it's covered. You'll be given a Dockerfile, maybe and they tell you to edit the Dockerfile to make it more secure.
Yep. So that issue has been resolved. So the user from root to specifying a user. That's why a user where it hasn't got to root capabilities. Also the image, like you guys said, the image version, base image, and also when you want to install multiple binaries, is put them all into one run. So you can, like Ali said, you can use the Dockercation capability, and also as Carlos mentioned, the expose. It makes it easier for your developers, and that's pretty much it. So you can't always have a perfect Dockerfile, but there are ways to make it better, if that makes sense. So that's pretty much Dockerfile, and we'll move on to the next topic, quite a heavy topic, but we'll pass it on to Hussein.
No problem, thanks for that. I wouldn't say it's as heavy as it should be, but it's heavy enough. So
we have a Docker image. Can we make it more secure?
Yeah, so now that we have our Docker image, we follow the best practices to create a good Dockerfile as lean as possible. And now what do we do next? We've created an image, we've uploaded it, or before upload, what we can do is we can sign our containers. So why would you want to sign your containers? Well, one reason you would want to do that is so you are able to verify that whatever container or whatever container image that you're using is actually the one that you want to use. So if you build your own Docker files, you can sign it with a specific key that only you know. And then once you upload it, or once you push it to your Docker registry, that key gets added to it. Sorry, someone is spamming the chat and distracting me. So yes, so what would happen is you would sign your Docker images, or you would sign your images, container images, and you would upload it, and then you can make this as part of your pipeline. So when you're going to be deploying your application, so part of the build pipeline would be that you sign your containers, and once you do that, as part of the build will be when you're pulling the containers, before you pull it, what you do is you verify that against specific hash or specific just basically verify it using a specific pattern. And then once that is verified, then you know that there hasn't been any change from your original image that you created and the one that you want to use, and the one that you've downloaded now and you're going to use. So if we go on to the next slide. So there's plenty of tools that you're able to use doing that. So one of the tools that we're going to talk about is Csi. What you would do is you generate your key pair, like you see in the picture here. Then you use those key pair to be able to sign your. Is it frozen? Yeah, you just specify the key pair that you just downloaded, and you sign your container image with it. In this case, it's GCR. But make sure that's compatible with whatever registry you're using is compatible with signed containers. I know ECR doesn't have that functionality yet, but it's coming in the future. And then you do a cosign verify of your image. So you give it a key, you give it the name of the, so you can see there's a public and private key being shared here. So once you create your key pair, it will create a public and a private key. So we'll use your private key to sign it, and then you use your public key. You can leave that in your CI server or any other tool that you have. You can import that there and then use that to verify it. And based on that, you can fail or pass that specific stage that you have there. So you can make that as part of your pipeline, or what you can do is, if your cosign can be installed using Helm, and if you do that, there's a functionality where you can make it part of a admission mutating webhook. So now when Kubernetes is putting in this image from GCR, ECR, whatever that is, that would make sure and that would check and verify if your images are right. If it's not right, then it's not going to run that container within the pod, so your pods don't work. So this way you can make sure that whatever image or whatever Docker image or whatever image that you're using, your container image, is the one that you intended to use, and this way you can make your whole environment safe. If there's any questions, put it in the chat. Carlos and Mohammed, anything to add?
Yeah, pretty much.
I think Csi is a new project. It also supports keyless, right? Keyless signing using OIDC providers. I can look for. Was a talk yesterday from Dan Lorick on YouTube. He gave a talk on Sixtor and talk about Csi. And Csi is being. I talked to Dan this week on Twitter, and he said that Csi is something that is being looked into building into the container build tools. So it's like not a separate step. It's like build me the container and just sign it, right? Like why does it need to be an extra step? Building and signing, and it's just built into code, kind of things like Docker, Builda, the different tools. And for the people raising your hand, you can raise your hand at the end. We'll have time for questions. Yeah,
please. It's a bit distracting. We've got a whole section.
I think someone's trolling or something. It might be that. So apologies, guys.
Yeah, so maybe we need to. You're the host, right? So you can.
Yeah, I tried to remove whoever that is. Eric Grace is still joining back for some reason. Please don't accept that name again, please. Oh.
Okay. So let's move to the next topic.
Yeah.
Any chairman? Is it me? Next one.
I think the next topic is.
Oh no, we're going to sign. We're going to check images. Yeah.
Yeah.
So these are quite a straightforward topic. Quick takeover, and so it also comes to the exam as well. So let's say, for example, you have an image you're using, and you want to scan it for like issues. And usually images have like critical issues, medium issues, high issues. So to scan it, what you normally do is we can use Trivy. Trivy is an open source tool that is still being contributed to. Another thing you can use Anchor CLI. That's another one. But Trivy is the one that is currently in the exam. It might put Anchor in the exam soon. But for now, all you have to do is Trivy, image, and then the image name with the exact version you're looking for. And Trivy does that scan for you. And it finds vulnerabilities or high. It tells you exactly what you need to look for. So in this case, as you can see, it tells you the vulnerabilities. And this is the code that is used. So if I search this code online and on Google, it will tell me what the issue is and how I need to fix it. It will give me guidance basically. And what I can do is maybe go to the image or the Dockerfile and then make adjustments or even change the image or update it. So that's pretty much Trivy, straightforward. And once you find the issue, you can delete the pod or the image that is being used in the pod. And that's pretty much for Trivy. Anchor is another one that we haven't used, but you can use that also. But that's pretty much Trivy for you. And yeah, so let's move on to security context. Carlos.
Yeah, we'll do security context. Share my screen. How are we doing with time? Yeah, Trivy is a nice tool. I use it in my CI/CD pipelines at work. Some open source projects that I do within Tecton. So it's very easy to use. You can run it from a container shell script and then scan and then stop your pipeline there. So we're going to talk about security context. Security context, let me open three websites that I have here. How are we doing with time? I think we're doing good with time. So this is the one best practices. This is kind of like the web pages that you have to mark in your for the exam. And security context is what basically tells the this is something that you put in the pod. So let's start with that. It's the pod. There's two sections on security context is at the level of the pod. So things that you put in here are kind of like the default values to be used in every container that is listed. So as you know, a pod can have multiple containers. The next section is at the container level. So on the container level, you can have, and for better or for worse, they're called the same. So one is called security context. The other one is called pod security context. But in the YAML, they call the same. Don't blame me. I didn't design this. But they take different fields. Some of the fields are the same. So if you provide value here, like run as user 1000, and you provide you run as user 1000 in security context, the container one wins, right? So it's more specific. And the ones at the top is like fallbacks. So for the values that are common between the two. If you want to see So I think we left off on explaining security context that is at the pod level. Security context has two sections, the top section that applies to all the containers, and then another one, security context, that applies to the specific containers. Both sections don't support all the fields, but the one at the pod level serves as a fallback. So if I specify run as user 1000 here, I can specify run as user a different value for this container, and then, like I said, run as user 2000, and this container run as 2000. And if I have it in this pod, if I have another container and it doesn't have it one specified, it will use the default one. So this serves as a default one. So I was going to share the two other links that are useful, I think, that are you can use in the exam. So the first one is basically the reference docs. So I think I opened this one, and these are the values that are on the pod. So these are the values that you can put in the pod. So run as user, you can tell it do not run as root, and you can also tell it like read only through file system. So every container is read-only file system. The other one is actually you can get from here. Is at the container level. So as you notice, this one is called security context. Is the kind, the one on the pod. The second one, it doesn't say security context. The kind is on the container. So we will look here. Security context is the second one. So security context. Actually, this is the one at the pod level. Let me look for the other one. The one. Let me see if I can find the other one. I think there were two. So this one is the other one. So we have two here. Right. Why is not? So at the container level, you have your security context, which you can specify here. And that's one at the container level. I guess I'll look at here. And then in the pod, you have the other security context. Let me look at here. It's called pod security context. So that's kind of like a little bit confusing and people find out. So this one is at the pod security context. This one is at the container security context. The kinds are different, but the name, the field of the YAML is the same. And they don't support the same fields. So you can see if you want to provide certain capabilities for the container, you specify at the container, you don't specify it at the pod level. The same thing for the file system group types, and then related to file system group, they're at the pod level, they're not at the container level. So there's just information for you to go through the different areas. Privilege is one that is very important for security purposes. Basically, it basically gives you equivalent to root on host, as you can see here, and that's specified at the container level. So it will be privilege, a one-day container to run as privilege. So it will be almost root. So let's go through an example, just a quick example to show like the mechanics. But like I said, the courses that I show go deep. The documentation goes deeper. So if we go back to the presentation, I'm going to try to do an exercise of NGINX. And NGINX is very popular. It's a container that you see on a lot of examples. But let's say that we want to make it have NGINX running a little bit more secure than the default way of running NGINX. So let's go to here, and then I'll switch to Kubernetes default. And then see if I have any pods in here from before. So let me delete all the pods. This is another cool way you can do -- all the resources. So it's clean. And basically what I want to do is security context. So let's say that I want to run NGINX. And I want to run NGINX, and I want to say run as non-root, like we saw in the Dockerfile. Even though if you put user root in that Dockerfile on the image, it's basically the image. What it's saying is like, when you run this process with this image, select root, this user if you can. So by default, Kubernetes out of the box, the open source one comes like, yeah, you can run things as root. So people get surprised about that. So I don't want the NGINX to run as root. So I'm going to do this pod like this. And we'll see what happens if I can run NGINX, the image NGINX, as non-root. So the Kubernetes will select another effective ID for that container. So if we do get pods, we see that we already have an error. So the image, usually you do kubectl pod NGINX run, and it runs out of the box, but it's running as root, and maybe you don't notice. But in this case, we want to make it more secure using security context, telling the container runtime, this is the values for the context when you run the process, aka the container. So if you do kdescribe, and we describe that pod, why it's not working, describe pod security context, you can see down here, let me hide this. it says, yes, it can pull the image, but when it's time to run the image, it's saying this image wants to run as root. So it actually put in the Docker image, put user root, like you saw Mo showing the Dockerfile. So this container will not run. And that's kind of like the contract. It's saying like that when you put user something in the Dockerfile, you're saying like this image or this program needs to run as this user. If not, I think we'll have issues, or I assume that we'll have issues. So so there's a mismatch. It's trying to run as not root, but the image is saying root. So then what we can do if we want to run nginx, so we need to either take the Docker, create a Docker file, take nginx, run it as not root, create a new image, or we can find an image from that somebody did that work to create an nginx, running the program, the open source program, and run it as not root that users will be user something else. So in that case, I have another image that I use a lot for a lot of my demos, and when I need to use nginx is from Bitnami. So I'm using Quay.io, Bitnami, and then this one in the Docker file, they don't have user root. So, and then that should work. So let's run that one now. Let me delete this pod, because why do we want pods that are not working? So we'll create the second one and see if we can get nginx working with security context non-root. So that's what we want. We don't want to run as root. I'm gonna do get pods, and now nginx is working. Woohoo! So we got it working. Then the next thing is we heard about immutable container images, immutability, or not allowing the program to dirty the container image, either like put files in it and then try to use it as a state. Or putting a lot of files that you go over the limit. And that for that, we can use another security context. And just as a different example, this context doesn't go at the pod level, it goes at the container level. And what I'm trying to tell the container runtime is, for this container, I don't want any of the process to write to the root file system of the container image where you're mounted. And if we run this, let's run this to see if we can run nginx even a little bit more secure. Maybe delete the previous one. Let's delete that one and create a new one. And this one will say read-only file system, read-only immutable container image. So, and then we do get pods to see if we can run it. And it's not running. It's a different error, right? So now it got far enough to start the process. But when you see crash root back off, it's like the program is having issues to run. So we need to check the logs. So we check the logs. We do logs and the name of the pod. And what you can see here is like the program, nginx program, had issues starting because it assumes that it can write to this folder, opt bitnami nginx tmp. And the next folder that was going to write into was /tmp. And I believe we put some files there, some temporary files, and it has issues. So it wants write access, and the runtime is saying like, no, Carlos configured this pod to not have to be read only. So how do we solve this issue and still run nginx but in a secure way? So the next issue, what we can do is, and this is related to security context, is like, then you have to give it like a PVC, like external storage, or a PVC or PV storage volume, or you can use an empty. If it's like ephemeral space, then you can use something like a volume called empty dir, and this is kind of like ramfs. And we're going to mount the two folders that I was trying to write into, the one from the error, and then I read the docs for this nginx, and it says that it also needs write access to tmp. So let's see if we can get nginx running in a secure way using security context and also kind of the best practices. So for that, let's delete the pod again. And let's see if we can succeed and get nginx working with the proper security context. In this case, the ones that we want with those two non-root and read-only. And then we do get pods and see if we're running. Voila. So now we're running, and it's a little bit more secure, running as non-root and running as read-only, the file system. Any questions? Or anything to add, Mo or Hussein?
No, I would say that was pretty comprehensive.
Okay, so I think next we move to OPA. What is OPA stands for?
Sure
I'll
thing.
pass it to Hussein.
Yeah, sure
Let
thing.
me stop sharing.
Let me share my screen. Okay, so now we'll talk about OPA and how we can use OPA within our cluster. So what's OPA? OPA is an open source project, which OPA stands for Open Policy Agent. I'm pretty sure a lot of the people that are in the security field will be very familiar with this. But you define your policies that you want to apply to your system using a specific template called a Rego template, or Rego template, as it's pronounced. It's written in Rego language. And once you do define that, you can use an OPA agent to be able to apply that policy to whatever system you want to do. You want to apply it to. In the context of Kubernetes and generally any managed Kubernetes or any Kubernetes, you can install OPA Gatekeeper. So now what we have is we have different versions of OPA, which is being compatible with Kubernetes. You have the version 1, version 2, and version 3. So Gatekeeper version 3 works in slightly different manner to how version 1 worked. So version 1 originally, what it would do is it would create a kube management sidecar, and then it would apply like what are the policies that you need to create. So these policies that we talked about, if I can share my screen to show you an example of what a Rego template look like. So this is how you would define one of the policies within OPA, which is firstly name your package that needs to run this. So again, use this again. So you define the package, which is auth in this instance. Then you would give it what it needs to do. So you tell it, allow if the input path is users and the method is post, and then you can define multiple sections like that based on all your needs and requirements. So now this can get a bit tedious. So with going back to our slide. We're going back to our slide. So that could get very tedious. So with OPA Gatekeeper, you could define that as a config map. So within Kubernetes, you can define that as a config map, which will be in the YAML format, and then pass that on to the API server. And then based on that, OPA will define create those policies and apply them. And then obviously the admission controller comes into play and starts querying your OPA agent to be able to enforce that or not enforce it. So now with OPA Gatekeeper version 3, it works in a slightly different manner. So now we're not creating config maps. Well, what we do is we create CRD based policies. So if you see an example of that, let me quickly just define quickly what's happening in this picture. So you can see like the API server and Gatekeeper, and then you have the OPA, which is the Open Policy Agent. So Open Policy Agent is the one actually doing the verification of the policies. And what Gatekeeper does is Gatekeeper is like a bridge between the API server and OPA agent, as you can see in the picture. So OPA agent is actually watching what are the different changes, and if need be, replicates any policies that needs to replicate. And admission controller is querying the OPA. So before it creates a resource, it will come to the OPA. Am I allowed to do that? Authorization happens, and then it goes ahead and creates any config, any CRD, any services, any pods, any deployments. If it's denied, then it won't go ahead and do that, and it will leave an audit trail, and you can look at the audit logs afterwards. So now, how would you create that? So I think it's better if I share the actual policy. So here, so you need to. So once you install it using Helm, it will create certain custom resource definitions, CRDs. One of them would be creating a template. So now what would happen is you would create constraints. With version 3 of Gatekeeper, you would create constraints for your policy. So what you would do is you need to firstly create the template to be able to define your constraints. So you can go through YAML, you're defining your constraint template, and then you're giving it name, what it does, and what the target is, which is the admission controller, which is Gatekeeper. And then based on that custom template now, you can create resources. So now we are creating a resources type of creators required labels. We've just created a custom definition using another custom resource definition using another custom resource definition. So now we can name it something else. Let's say if we say services need to have SVC in their name, then we can create a new custom resource type of KTS requires -SVC in name, and then give it all of the different parameters that we require. And then obviously you give it your rego. And then now, once you've defined your rego, once you create your custom resource here, then it would change whatever you've inputted here into your rego, and then that's how the OPA then uses that to define what the policy is. So in this case, we've created a KTS required label, and then we've named it. Name says must have HR in it. So we're saying that the kind it applies to namespaces, and the parameter is it should be labeled HR. So now if we apply this, what would happen is you would have your admission controller once it's created a resource, admission controller will go, okay, this is what I'm trying to do. Am I allowed to do it? If it has the name HR in it, it would allow him when you create the resource. If not, then that would get denied. And similarly, you can create whatever you want to. So another same one requires namespace, but this time, instead of saying HR, you can apply finance, and you can create multiple flavors of this. So it depends on what your imagination is and how far you want to take it, but it's a very, very powerful tool to do so. So now what you can do with OPA is you can look at ways of the ways to use it would be, let's say if you want to define that your images or your containers should have resource limits, you can define this that every deployment or every pod that I create should have the resource limit set. If it's not set, then that will get denied. So this is a way to regulate your and this is a way to audit your environment and to give enough flexibility to the developers and the users of the cluster, but still have like security control around it. So not everybody is doing whatever they want. You have specific best practices already defined using OPA, and then once that is applied, then people are able to do whatever they want. So this way, your security posture is good, and it's not just willy-nilly people are doing whatever they want. Any additions to that, guys? Mohammed and Carlos?
So I started looking at OPA and Kyverno. Kyverno is another option. I think that in the exam they cover OPA, but in terms of benefits is as I started like learning about admission controllers and writing my own admission controllers, you cannot write. The thing is, you can start with that, like writing a little Go program or Python program that is very easy. I have some repos out there that is like you can validate, for example, just a validate read only, doesn't have to be a mutation, but validate a request. Either somebody wants to create a secret, somebody wants to create a pod, somebody wants to delete something, right? Or somebody wants to create, usually it's like when somebody wants to create something and you are checking that they put the right labels or they didn't put replica equals 1000, right? Or that the security context has this or this, right? You can so you can either validate or you can also mutate. Like if you didn't specify a certain security context, like I show, I'm going to go ahead and add it for you, so you don't have to have that YAML in your Git repo or you do it GitOps. But the thing with OPA brings that a little bit higher level is that if you write your own admission controller, you only have context of that one request. You don't have context about the rest of the resources. So for example, one cool demo that OPA has, example is saying like, that you cannot do with one request is like make sure. I think I'm trying to remember. Make sure that this label key is unique across all the namespaces. So you need to know the labels of all the namespaces to take the decision. Is I going to allow this namespace to have key, I don't know, Carlos equals Santana, and only one namespace should have a label like that, Carlos, right? Because maybe he's the owner, or maybe like one person can only be the owner one namespace, for example, like in common practice. So you put in like owner equals Carlos. So there should not be another namespace, owner equals Carlos. So, but so if you implement one admission control, you cannot do that. So with OPA, what it does is running in the cluster and gathering that information, also caching it. It's not hitting the Kube API live, so you're not like hitting the Kube API a lot, but it's caching that into memory. So that's why in Rego you have the option of querying that cache information, saying, "Give me all the namespaces," and then do your little program saying, "Find all the namespaces, check the labels, and say, make sure that this new namespace being created is the only one that has owner equals Carlos and not the other ones." And that's very powerful because then it takes the scope of the whole configuration. And then the last thing is, people don't know it, but when they write these little YAML files as instances, you have instances, you're creating a CRD. So in retrospect, you are like a Kubernetes operator creating CRDs of your own using these templates. So they make it a little bit easier for that. And then you have the status at the bottom that you can have an audit saying not the at creation time, but then like you apply the policy and then goes back and queries all the things that are not are in violation, for example. And then you can query saying like, we didn't know for these months, right, before installing OPA that we had this violation in place. So it puts the policy in place for new things, but it goes back and queries the information. So I'm very excited about this type of extension type of policy in Kubernetes and stopping. It allows for more innovation around policy than letting that policy innovation be in the core Kubernetes, like before. PSPs was one, right? But PSP is just a policy, but people couldn't extend it, or people didn't find. So OPA and Kubernetes are kind of like the two projects that are very, very popular. So I'll leave it like that, but I think that's my experience.
That's definitely the case. And using CRDs makes it open to so many different use cases, because now you can create even more custom whatever you want to create at that point. So your imagination,
yeah, you can use programming to do it, but with the declarative way of creating CRDs, right? With a little YAML, you're creating your CRD.
Indeed. But it's creating like admission controls and creating like little programs quite labor intensive, whereas YAML, pretty much everyone can do it. So it's much easier and much more powerful way of just doing it. But yeah, really exciting thing with the gatekeeper there. So moving on. I think it's you, Carlos, is it? Or CIS Benchmark?
Yeah, it's talk a little bit CIS Benchmark. I got excited when I started looking into this, and that I think it was this year. I think it was summertime. With this COVID, I lose track of time, but I think it was around summer. NSA put something out there, CIS Benchmark of like basically they're codifying the best practices to configure Kubernetes. So answering the questions like, is my Kubernetes cluster compliance, right? And that depends of which version of Kubernetes and which benchmark you are going by. So there's one for OpenShift. I work a lot with OpenShift. So OpenShift put out one. There are a little bit deviations from the standard Kubernetes. So at the end of the day, almost all of them look the same. They work the same. And there's tools to check the Kubernetes cluster to see if it meets the benchmark. So CIS just put out the standard, just a PDF. They have a tool also, but there's a tool called KubeBench that we're going to see in a second. I can show that. But basically, it checks. NSA put one. OpenShift has one. I think the vendors, AKS and the different vendors has theirs, and then the one from CIS Benchmark. So let me show you an example on how, for example, in the test they ask you, hey, can you fix something in the cluster that doesn't meet the CIS benchmark. So let me share my screen. And I usually these demos I try to do them in Minikube on a Mac. I have a Mac or Linux, so people can practice in their computer. So I have kind of like this CS benchmark and this kind of question saying, check that Kubernetes deploys securely by the CSI benchmark. You don't have to. I don't think you have to install Kubebench. It's already there, so for you to run it as in the host. And you run it against the cluster, and then they give you back a report saying these are the type of things that are not meeting, and also a recommendation how to fix it. And sometimes they're easier or not. And then later we'll talk about running this automatically, right? You want to have an operator for a cron job running this automatically. So I have it. Have Kubebench here. Let me close this one. And just as a reference, we can put the link. Bench, I think it's this one. This is the repo. I give you the information about how to install it in Linux. Usually you can install it in Linux, but to make it super easy, they offer you a job. I think I have a job here. Where is the job? So they give you a job file. So I'm going to run this job that runs the Kubebench command line interface, and then basically mounts certain host paths to it. So because it needs to integrate, it needs to see like the Kube API YAML files, the config file from kubelet, and different configurations. So if I go here and I run this in my Minikube, I have it here. Where is it? Kubebench. So that's the question for the exam. I say, okay, fine, let me practice. And I'm going to run the same job that you saw there, but I made a small change saying that this is version 122 on Kubernetes. In Minikube, it wasn't able to detect it because of missing binaries, but I'll put this in a JSON, people can run it. So let me see if I have any jobs. Get jobs. No job. So this could be a pod that runs into completion, but a job, basically that's the definition of a job. Just run this one task. So we're going to run a pod that runs that command or a script and then ends, and then we'll grab the logs. And the logs are basically the thing that you want to read. So the job is created. If I do get jobs, right? It's there. So one job, it ran. If I do get pods, the pod got completed. This is from previous example security context, but it's this one. It ran, and now we have logs. So basically you can do logs, Kubebench, yeah, and get the logs. And this is the report. So if we go back to the top, it tells you the summary. So a section. So it goes. Oh my God! So it's very long. But in the exam, it will give you like 1 or 2 things to fix. So it's running. This is the 1 dot. So it's for section 1 dot, 2 dot, like chapters. So this is checking the no security configuration, and it's checking. It's expecting the config file, the YAML files for Kube API, scheduler, the different Kubernetes controllers. And then at the bottom, it tells you like also checks etcd, and it tells you like how many passed, how many failed. So in this exercise, I think I selected 141. Let me see if I can find 141 here. And 141 says that it failed, right? So it says like it didn't pass. And then at the bottom, you look for 141 and will tell you how to fix it. So we look here, 141. So it says that the file Kubernetes manifest kubescheduler.yaml file on the master node, and is set and it's not set properly, right? So it's telling you edit that file and set it properly to this value. So basically, what you need to do is SSH into the node. So in my case, I'm going to do a Minikube SSH. I'm going to make myself root, and then I can see that I have the files here, right? And the one that I was saying was scheduler. So I can VI that file scheduler, and then I check the flags. So these are the flags that this scheduler is saying, and it's saying that I was missing one of them. And I can come in here, right? Don't put it here because this is the program. But you can add a new line and just add it here, right? Profiling equals false, and then save it. And this will cause the pod for the scheduler to get restarted. You get a new container with that flag, and then you can, in this case, kill the job, run the job Kubebench again, and make sure that 141 is passing. And this is something that you can run manually, but in practice, in production, something like I know about OpenShift. OpenShift has an operator, compliance operator, that will run in a schedule, because it's not checking that your cluster is compliance today. It's like it's compliance tomorrow, and it's during the weekend and going forward. And if it finds something, it can alert you, right? Send you a notification, or can actually figure out how to make the changes, because there are codification around this benchmark. So it's very, very useful, that operator. Or people just running a cron job, right? Run like I had here, instead of a cron job, have a job. Make sure you're always passing. If you're not passing, just send a notification through email or Slack or something like that, or Cloud Events. So that's for Csi Cis Benchmark. So that's kind of the mechanics related also to the exam. Any questions on that one?
I think you covered most of the stuff, but in the exam, they might ask you to do maybe resolve more issues, right, in the Kubebench.
Yeah. Give you like 2 or 3 things. Fix these 3 or 4 things, right? And you run Kubebench once, right? Fix the things, and then come back, run it again. Make sure you're passing. So. Not big issue. So the next one is, I think we're closing thoughts, and then Q&A. So I think we already covered Csi Cis Benchmark. I already talk about the automation, right? I'm a very key person of automation, all the things. So automating also the running of the benchmark, and then logging and audits. So I don't know if you have thoughts about logging, and then this is also applicable to like manage Kubernetes, right? You're running Kubernetes in EKS, IKS, GKE. Logging is different.
Yeah. I just wanted to add to the automated compliance and operators for Csi Cis Benchmark for EKS specifically. Not with managed Kubernetes, it can be a bit difficult because a lot of the deployment and the worker nodes are kind of heavily monitored or heavily configured by the cloud provider. But in some cases, a lot of the times people create like specific programs, or they would create like a pod or Docker image or Helm chart to be able to run Csi Cis Benchmark internally on like a scheduler. And then I know someone did that for EKS. I'm not too sure if that's been done for AKS as well. But if it's not something that is part of the core functionality already, you just need to look at the wider area or the wider network to see what else is available. But there are some specific tooling around doing automated compliance in EKS.
Yeah. So manage, like EKS manage, and also in IBM IKS, that's the good thing if I manage Kubernetes. You don't have master nodes, right? You don't have access. It's a good thing to not have access to the Kube API service, because then you have to maintain it, or how do I scale etcd, right? So those, and usually manage Kubernetes, you delegate that. And I think that talks a little bit about the shared responsibility model, right? If you use a managed Kubernetes cluster, you do get nodes, but those are only worker nodes. You don't get control plane nodes.
Well, drilling down into a bit more, as compared to, using the shared responsibility models, and a lot of things come into play where, like, points underneath it, KMS encrypted and KMS encryption and etcd encryption. Well, etcd you don't need to worry about that much, but for some of the managed workloads or managed clusters, the secrets generally are not encrypted, but there's a functionality where you can add specifically for EKS where you can add KMS keys to your cluster, and what it would do is it would encrypt your secrets with KMS, with that specific KMS key. So now that's not on by default. So as part of the shared responsibility model, you know that you need to encrypt your data at rest. You can turn that functionality on. And another thing is having a private cluster. So you don't want your master node to be available on the internet. So you need to create private endpoints for your cluster and need be access it using some sort of VPN or some sort of bastion host. You never want your control plane to be out in the open. So once again, as part of the shared responsibility model, Kubernetes administrator should identify that and be able to put this in place and have this as part of their design when they're building their clusters.
Yeah, the private cluster and private subnets comes a lot, at least in enterprise. Like in example, in IBM Cloud, we have financial services cloud, and that by the spec, by the compliance to meet some certain standards, that kube API endpoint, that IP address to the kube API, so you can kubectl cannot be in the public internet, because one is unsecure, and two is like there's actually bots looking for vulnerabilities in Kubernetes. Like they're scanning the web to see if they can hit a kube API server from running 1.17 or running 1.18, that there's a CVE patch that they haven't patched yet. And that's how you get hacked, right? Because you're running 122 today. Guess what? In a year or 6 months, you may be still running 122 and 125 is out, right? And you haven't patched things. So, but usually we manage Kubernetes, and that's a responsibility model. The cloud provider will give you the option to upgrade, but it's your responsibility of like knowing when to update or how to update that you don't have downtime. But you need to click the button to update, right? The cloud provider will not click the button for you. So you need to pick up the patch and then, do the worker pool, the worker nodes, just refresh them to the new version. So keeping up to date is part of being secure, right? Keeping up to date with the versions of Kubernetes, with the CVEs, and then in production, Kubernetes is one layer. Then the next layer is the workloads, right, that you're running on them. What are the tools and the secure supply chain and your workloads running in production that actually they're secure, like they don't have access to the internet. And I think I put this one here because it's a misconception that I think I see a lot by people starting, is when they like, let's say they buy the provision a Kubernetes cluster and they have two VMs, two nodes, and then one pod sits in one pod, right? One service sits in one node and the other service sits in another node. That happens like that by pod scheduling. They think because the two pods are inside the cluster, the communication between the two pods is secure because they're inside the cluster, right? They think the cluster is like something inside, but the thing to understand is like there's no inside. It's just regular VMs, and when you go like configure HTTP microservices, they're running plain text. Like one VM talking to another VM, they're running in plain text. So the only secure thing that you have is like the way you configure your security group in your subnet or VPC. But to be compliant with things like HIPAA or HIPAA or PCI, that connection between those two VMs need to be secure with HTTPS. And then that's where and also mutual TLS, like the server needs to authenticate the client through a certificate. So how do you do that? Do you like customize your Docker files and applications, or you put a sidecar, like using a service mesh? That's something to consider, but something to be aware when you're getting into production.
Yeah, indeed, definitely. I think we've covered most of it. I don't think we spoke about logging and auditing. Well, once again, just quickly running by it, where this is options that are available as part of the shared responsibility model, but in certain cases you need to turn on, and in certain cases it's on by default. I know in EKS it's on by default. I don't know for GKE and AKS if the managed workloads, because if you're running Kubernetes by yourself, creating the clusters and managing the clusters, then you're in a hell of a pain. And then just all of that falls on you on top of managing the clusters. But generally, if it's a managed cluster, then a lot of this is on by default. But once again, you need to be able to log them properly and obviously use the more secure way of doing so. You're logging it using HTTPS if you're sending it to a HTTP client. And what was the other one? When you're keeping your logs, make sure that it's in a separate account by itself, and the right parties have access to that log. Sometimes, even knowingly or unknowingly, if you're working, firstly, if you're logging application logs, then sometimes people would by mistake leave secrets in there or things which are sensitive, and you don't want people to have access to that. To make sure that you're segregating that and obviously encrypting everything at rest and things of that nature. And obviously, if you're going to be doing internal logging, then you'd be using the likes of Prometheus, Grafana, and your Elk stacks and all of that. And again, once again, the communication between all of these components should be via MTLS, because you want to have zero trust security here. Just because something is internal and it's not an external service, you still need to verify that this is a secure and a safe service to connect to. You want to add something to that, Santana, or Carlos and Mohammed?
Yeah, logging and monitoring is DevOps is a large environment. There's a lot of aspects to security that you mentioned. Secure at knowing things like secure at rest and secure on traffic. Things that need to be compliant with FIPS 140-2, right, to be FIPS compliant. And also, like you said, the cloud provider will have logs, but the cloud provider gives you the option, right? Like, do you want to aggregate the logs across all your clusters? And then how long do you want the logs stored in a fast access area? And also, like, you want to archive them, because some companies need to archive them for 3 years, for example. And then you archive them in maybe to a cloud object store bucket, and then you don't secure the bucket. Right? And you need to secure everything, and then when you're transferring those files need to be also secure. The audit part is about Kube API audit. At least in IBM Cloud, you don't have access to, like, you in the CKS exercise, you need to configure the Kube API to logs, the Kube API logs, right, to do auditing of everything that's happening in there. In IBM Cloud, we give you a good default one, but you need to enable it. Like, you need to enable like a trampoline pod or service that the Kube API that we implement behind the scenes will send the log there, and then you send it to wherever you want. Like, you want to send it to log DNA, maybe you want to dump it, but that's a shared responsibility. The provider gives you, I guess, enough Kubernetes, but the other half you're responsible for, right, to go in production.
Yeah. Well, I've got nothing else to add to that. I don't think we have enough people for question and answers, but if you have any questions that you wanted to put forth that we can answer together, or should we say?
I think because of the situation, a lot of people drop.
Yeah.
I gave the link to a few folks to come back, but I think we can end there, and then Mo would send a message to the group, and these are links in LinkedIn. You can find us in LinkedIn, and there you can see our profiles and the things that we share. So probably I will do a small post with a few links that I talked to here today, or we can just do one common post. That's also good.
Yeah, definitely.
So I think Mo is back. You want to close this?
Sorry about that. I had a bad connection. I'm just connected back. Yeah.
No problem. Yeah, I think we've said that. That's all for now, because we don't have a lot of people online, so there's not going to be any questions and answers. I don't know what you want to do about that. If you want to take questions separately and session, but that's up to us to figure out. yeah, I think with that, I think that's the end of that. Did you have any closing remarks, Mohammed, that you wanted to share with the community, or it's okay to go?
I just want to say thanks. That's it. Thank you to first of all Hussein and Carlos. Really appreciate you taking the time out to join us. Thanks a lot. And once again, thanks to the community. Apologies that some of you guys couldn't attend the second part live. It will be recorded and shared to the community on LinkedIn. So that's pretty much from.
We'll merge the 2 sessions into a video and share so people can see it. And unfortunately, if we do this again, we'll select another platform to stream.
Definitely, maybe from Google, yeah.
Or take questions through a different medium. Maybe we'll do a YouTube stream or something.